Dear top learners, welcome to today's mathematics lesson. My name is Sepang Mapotsani. This lesson is brought to you by Northern Cape Department of Education in collaboration with Pagama Research and Development. Now, the 12s, in today's lesson, we are focusing on mathematics paper 1 revision. Remember, paper 1 is 150 marks. We're only going to focus on questions from question 1 until question 5. Now, we'll focus on algebra and equations, including inequalities, which is about 25 marks. We'll focus on sequences and series, question 2 and question 3, which will also amount to 25 marks. And we'll focus on functions, which will be question 4 and question 5 in our paper. By the end of this lesson, you must be able to identify the structure for the paper 1, the mathematics paper 1, and we will focus on the following topics. We'll focus on algebra and equations, including inequalities, sequences and series, and functions and graphs. Now, this is the structure of our grade 12 paper. Our question 1. It is algebra and equations. Question 2 and question 3, that is where we have sequences and series, patterns and sequences. Question 4 and 5, we have functions and graphs. Question 6, finance, growth and decay. Question 7 and 8, including 9, where we talk about optimization in 9. It is differential calculus. And question 10, which is our last question, it will be probability. So you can see the weighting there, algebra and inequalities, which is topic for the day. It is 17% of the paper. Patterns and sequences is 17%. And the functions and graph, it is 23% of our paper. Now, question 1, it focuses mostly on quadratic equations. You must remember, what we are dealing with under quadratic equations, in most cases, you will be required to solve for x. When you are required to solve for x, you must follow the following steps. You must check if the equation is given to you in a standard form. If it is not, you must write it in a standard form. Thereafter, we check if there's a common factor. We factor out the highest common factor. So the second step, we factor out the highest common factor. Now we check, after factoring out the highest common factor, do we have a binomial or a trinomial? When you have a binomial, we can check if we have two perfect squares, we'll use the sum or the difference of two perfect squares. And if it's sum of two perfect squares, it cannot be factorized. So that one you should actually take note of them. Right, we proceed. We go there and say if it's a trinomial, we'll factorize. The factorization is by factoring. We can also use a quadratic formula, or we can complete the square. The quadratic formula is written there on the side, and we know that in our quadratic formula, we know that it's f at x. It's given to us as ax squared plus bx plus c. Now, in this case, now we go to this quadratic formula and substitute to say what is a. We put a, b, in the space of B and C in the space of C. That is how the quadratic formula is given. So this is the format or the form that you must arrange the quadratic formula to be in. Another thing, question 1 again, it also focuses on the nature of roots. However, these nature of roots do not only focus on question 1. They also can apply to sequences and series, can also apply to we can also find them on functions. We can still find them on calculus. So they are utilized throughout our paper. Now, we normally use what we call a discriminant to determine the nature of roots. Now, under nature of roots, what are we focusing on? When we're saying an equation or a graph has our real roots, it means on our graph, when you plot it there, you will have some x-intercept there. So that's what we mean, or that's what we are focusing on when you talk about the nature of roots. This discriminant, it comes from It is this part, the one inside of our square root from our quadratic formula. Now, this is what we're saying. When we're saying nature of roots, when we're saying a certain graph or a certain equation has roots, we are saying in this case, it has x-intercept. If there's no root, it means the graph is either just floating there or maybe just floating somewhere there. So that one will say it does not have any root. Now, we use the discriminant as it is given there. That means you are supposed to have an equation in a standard form, which is just do that. F at x is equals to ax squared plus bx plus c, where we know in the space of B subject the value b, a, and c. So we are supposed to make sure that when we are determining the nature of roots, we have our equations in a standard form, right? When the discriminant is less than 0, that means we have no real roots. That means we do not have any x-intercept. When the discriminant is equal to or greater than 0, we have real roots. That means our equation or our graph, it is intercepting with the x-axis. We proceed. When the discriminant is greater than 0, remember this is equal to or greater than. So when it is equal to, that means we have two equal roots that are there. So the two equal roots will mean it will be 2, it will intercept at 2 maybe, negative 2 maybe, and maybe 2 in that case. So it will have equal roots in that case. So that's what we're saying. What we're saying, this is equals to 0. No, just need to take them. So this is to say, when we're saying we have two equal roots, that's when we talk about the discriminant being equal to 0 in that case. So now what are we saying in this case when it is equal to 0? It means it will intercept there at that point. There we go. Now, when you look at this one, when the discriminant is greater than 0, we have two unequal roots, and those two unequal roots, some can be the perfect squares, and others can be not perfect squares. When they are not perfect squares, we get irrational roots, and when they are perfect squares, we get rational roots. Now, this is what we're talking about. Now, let's look at this. Two real roots, you can see it's intercepting twice. One real root, it is intercepting the x-axis once. When you say no real roots, it does not intercept with our x-axis. Now, we look at this one. Also, this is just the same two real roots when it's the current is negative, it's facing down. Two real roots again, one real root, we look at no real roots. So that's what we are focusing on. Now, the 12th, I will give you 15 minutes to complete the revision for question 1. So this question, I'll give 15 minutes to go through it. Now, welcome back, grade 12. Now, let us look at this question. So the question is 1.1, we have 1.1 and 1.2 and 1.3. So 1.1, we are required to solve for x. 1.2, we are required to solve for x and y simultaneously. And 1.3, we will have to determine the value of m and n. Now, let us focus on the solutions. Now, let us look at the following. 1.1, it says solve for x. So what are we given? We are given a quadratic equation then, which is x squared plus x minus 12 is equals to 0. So what we can see that is, first step, you must check if this is in a standard form. Yes, it is given to us in a standard form. So what do? We now factorize. I believe we know how to factorize, but remember, how do we factorize? How we normally factorize is that we look for the factors of negative 12. These factors must give us the middle term. When you do what? When you subtract them, but they must give us the 1 there. When you multiply them, they will give us the 12. So the factors of negative 12 is 1. We have 12. The other one, it will be 2 and 6, and we'll have 3 and 4 in that case. So what we see is that which factors, when we subtract them, they will give us 1, because we are looking for that coefficient there. Which ones? These ones, they won't give us 1. These ones and these are the ones that are going to give us the 1 that we are requiring. Now, if these are the ones that will give us the one, we check now the signs. In terms of the signs, you say the negative sign here, it means we have different signs. We must have a plus and a minus in our bracket. So, in other words, when we're working with that negative sign there, what are we supposed to do now? We say, okay, plus and a minus, and this sign says the bigger number will take the plus. So the plus is going to be for 4, and this will give us the 3. So that when we say negative 3 plus 4, we get a positive 1. If you swap the signs, you'll see the side. When you swap the signs, you'll get a negative 1, and the answer it is supposed to be a positive x. Now, what do we do? Open two brackets. We have x plus 4, that s and x, the positive 4, then we have it. So it is our factor there. And we have the minus 3, which is what we have in that case. Then we solve x equals to 3 or x is equal to negative 4. So that's what we have for 1.1.1. Number 2, it says solve for x again, 1.1.2. We are given 3x squared minus 2x is equal to 6. Answers correct 2 decimal places. This already, it gives us a clue as to what to do. So when I'm saying it gives us a clue, in this case, it means what are we supposed to do now? We're supposed to use the what? The quadratic. So here we are supposed to utilize the quadratic. But before we do that, we must have this in standard form. So the first step is to transpose the 6 to the other side, which is our left-hand side, and we have it in a standard form. When we have it in a standard form there, we can now see that our A, it's going to be 3. Because remember, the standard form of this is f at x is equals to, or y is equals to ax squared plus bx plus c. A, it is this one, that's A. B, it goes with the sign. Then C together with it. So this is my A, B, and C. So what do I do now? I substitute everything in our quadratic formula. Remember, quadratic formula is x is equals to, we can have it there, it's b plus or minus the square root of negative b, then the square root of negative b squared minus 4ac all over 2a. Now we already do know that a b is negative 2, so it's negative 2 and negative 2 will give us a positive 2, plus or minus, we're introducing the square root there. Then we go into the bracket to say, in the space of b, which is this b now, we'll say substitute negative 2 squared minus 4 into a, which is a is 3, multiplied by c is negative 6 all over 2a. We press our calculator and we get our answers as x is equal to 1,79 or x is equal to negative 1,12. Remember, there's 2 decimal places. We have it as 2 decimal places as we have right there. Right. Let us proceed. Question 1.1.3, we're still solving for x. So what we have now, we have a square root of 2x plus 1 is equals to x minus 1. So what do we do here first? We need to get rid of the square root. So we'll square both sides. So we have squared both sides. Then we proceed. After squaring both sides, we now know that this and that will remove our square root for us. Then on the other side, or which is our right hand side, will remain with x minus 1 all squared. Thereafter, we just expand here. Then we have 2x plus 1 is equals to x squared minus 2x plus 1. Thereafter, what we do, you simply on this step, what we did here was, we just said, okay, we transpose everything to one side. We said x squared minus 2x plus 1, which is this one. I'm actually just swapping the side. We'll just now say minus 2x, then plus, minus 2x minus 1, because 1 is positive, is equals to 0. So we transpose this to the other side. So that's what we're going to have. It will change the side to be negative, it will be negative. Thereafter, what we do, the negative 2 and the negative 2 will give us a what? A negative 4, which is what we have there. And the plus 1 and minus 1 will cancel out each other. Then we remain with x squared minus 4. So when we have x squared minus 4, what we can see there, we have something which is a common factor there. So we factor out that common factor. So our common factor in this case is what? Is x. X is here, x is here. We factor out x. We remain with, for the first one, we remain with x only. Then minus 4. What happened there? We divided with x again here. When we factor out this x, we remain with x, we remain with 4 alone here. Thereafter, we can apply the product rule that will say to us x is equal to 0 or x is equal to 4. So that's what we do in that question. 1.3, we have an inequality now. For 1.4, we have an inequality. So we are given that x squared minus 3 is equal to or is greater than 2x. First thing, you write this in standard format. What do? We transpose that 2x to our left hand side. Then it's going to become a negative. So we'll have x squared minus 2x minus 3 is greater than 0. Then what do we now do? We now factorize this one. So when you factorize it there, the factors of 3, when you subtract them, they must give us 2. So the factors of 3, it's 1 and 3. So those are the factors of 3 we have. And we check. They must have different signs. And the bigger number must take a negative. So the bigger number in this case, because we want this to be negative 2, the bigger number is 3 to take a negative. This will take a positive. Then we have x minus 3 for this one. And we have x plus 3 for that one. So this will give us x minus 3. And this will give us x plus 1. So that's what we do, or that's what we do there when we're working with the vectors in that case. Thereafter, we look for the critical values. Our critical values in this case, x equals to negative 1. And we have another one which is x equals to 3. So we plot those critical values in our Cartesian plane. We have negative 1 there, we have negative 3 there. Now let's look at this. This equation said to us where this is greater than 0. That means we're looking for the values where the graph, because this is a quadratic equation, or this is a quadratic function, we're looking for it where it is greater than. So when it says x is greater than 0, it means it is above the x-axis. So those are the values that we're looking at there. So we're looking for those values of x where this is above the x-axis. Let's now check. We can see that as we draw our graph, going that side, going that side. So below the negative 1, we can see we are above the x-axis. And after 3, we are above the x-axis. So we can see that here, where is the graph between negative 1 and negative 3? Where is the graph? The graph is below the x-axis. So x greater than 1, it means here. And our x less than 1, it means below the x-axis. I mean, sorry, less than 0, it means below the x-axis. So greater than 0, above, less than 0, below. Right. So that's what we are talking about in that case. So if the whole function, I'm just going to say function, not the x. So when you say the function is below x-axis or less than 0, it is below x-axis. So that's where the f at x is below. Then where is f at x above? It is at that point. So now what we do, we now know that x, we have it there is to say it is going that side. So x is less than 1 or x is greater than 3. So x is less than 1 or x is greater than 3. We can write this, however, we can say x, it must be greater than 3. Then we can see this, all of this, they must face to the same side. So all of those inequality signs, they will face to the same side. Then what do we now have? We can now see that the negative 1, actually, it is on the bigger part of that inequality. So we have the negative 1 that side. X is on the smaller side. So I just rewrote this as it is. So this is the other option that you can write it in. Simultaneous equations, they say solve for x and y simultaneously. So what we do, we have first equation, we label equation 1, we label the second equation. Then from these two equations, what are we going to do in this case? From this equation 1 and equation 2, we're going to use a simpler equation that's going to assist us to find either x or y. So we check number 1. Can you manipulate equation number 1? No, it looks a bit hard to manipulate them. So when you look at it, there's a fraction already. But let's check equation number 2. It's not that hard to manipulate. You can still manipulate it. However, we just look for an easier option. Equation 2, yes, we can see that I can easily work with x there because there's a coefficient of 1 and it is not a fraction. So what we do, it is from equation number 2. So in this case, from equation number 2. So what we do now, we just transpose this 2 to the other side. We have 2y minus 2y minus 2. So in this case, we have x is equals to 2y. We transpose this to the other side, it becomes negative 2. Then what do we now have? We have what we call equation number 3. So because we have derived equation 3 from equation 2, we cannot substitute back into that equation. We substitute onto the other equation, where in a space of x, you see it says x is equals to. So where there is x, you put what? You'll put 2y minus 2. So that is what we do. We have that equation number 1 there. So we can say it was 1 over x. So where there was x, I put 2y minus 2 plus 1 over y is equals to 1. Then we proceed to say, okay, from here, we look for our LCD there. So we work with the LCD in that case. Then when we work with the LCD, we now find y plus 2y minus 2 is equals to 2y squared minus 2y. So that's what we have. Remember our LCD in this case. The LCD in this case, it will be, for this one, it will be the 2y minus 2, and which is this one, and it will be the y also in that case. We can just distribute the y into our bracket, then we'll have 2y squared minus 2y. So that is our LCD that we work with. Now, when you're working with this LCD, we notice that, okay, for this to be like 2y times y, so 2y squared minus y, 2y, what are we supposed to do? We multiply by y. So that means for the first one, so what we did there is the following. We had 1 into multiply by y, because ours is to get 2y squared minus 2y. So we multiply the 1 by y, then we proceed to say plus. We can see that on this term, the second term, then what we see that is the following. What we see now is that we only have y. So we must make it 2y squared minus 2. So what we do, we'll have to multiply that 1 with 2y minus 2. So that's what we did in that case. It's equals to, so it's equals to, which is this one. It's equals to that one. I'm just going to find space. So on the 1 there, it's equals to 1. So the 1, it needs everything. So it's 2y squared minus 2y. So this will multiply by 2y squared minus 2y. So that's what we did right there. So what we do after that, we'll drop our denominators. Then we see it's y, we have the y, then we have 2y minus 2. It's equals to 2y squared minus 2 in that case. So that's what we did right there. After that, we write in a standard form. We transpose everything to the left. Then we work with the like terms. Thereafter, what we now have, we have 2y minus y into y minus 2 is equals to 0. So we are now factorizing what we had right there. Then when we factorize, we find that y is equals to 1 over 2 by applying the product rule, or y is equals to 2. Thereafter, we now substitute what we found. We found the values of y. So we take these values of y, we substitute them in equation 3. Then we will find the corresponding x values. So equation 3 is x is equals to, already is given in x format. Then we just, where there is x for the first one, So where there is x, what did I do there? I substitute 1 over 2. So the second one, for the second part, where there is x again, so where there is y, I substituted what? I substituted the 2 in that case. Then we have our final answer as x is equal to -1, and in this case, x is equal to 2. So that's what we had in that case. Now, let us look at 1.3. 1.3 says, we are given 2 to the power m plus 1 plus 2 to the power m. It's equal to 3 to the power n plus 2 minus 3 to the power n, where m and n are integers. Determine the values of m and n. So in this case, what are we doing? We'll find the value of m and n and we add them together. So what do we now do? We code down the question as it is. Thereafter, we'll also apply what we call the laws of exponents. Remember, laws of exponents is x to the power a multiplied by x to the power b is the same as x to the power a plus b. So if we can check in this part, what do we have? We have it in this format. So what we do now? We have to reverse back. So to reverse back, what do? We now separate. We'll separate that 2 to the power m alone, multiply by 2 to the power 1 plus 2 to the power m. Then we also apply the laws of exponents to that 3 to the power n plus 2. So what we now have is 3 to the power n multiplied by 3 to the power 2, or 3 squared, minus 3 to the power n. Thereafter, we check between this side and that side. What is common there? We have a common factor, which is 2 to the power m. We pull out 2 to the power m. Then we remain with this one, which is 2 to the power 1, plus, then we have only a 2 to the power n. When you divide 2 to the power m and 2 to the power m, we remain with 1. Then that's why we have the 1 in that case. It's equals to, we check also this side. We look for any of the like terms. Now, if we can check 3 to the power n, it exists both sides. So it is our common factor there. So we take out that common factor, which is 3 to the power n. We remain with, for the first one, we'll remain with 3 to the power 2 minus this own 3 to the power n. Then we divide the 2, remain with 1. Then you remain with 1 in that case. Right. Then we proceed. We now say, okay, whatever is in the brackets, we just add them together. In this case, it's 3 to the power 1, which is 2 plus 1, gives us 3. It's equals to 3 to the power n. Then we have 9 minus 1, which is 8. Then that's what we have in that case. What we now do, we apply the laws of exponents to that one, so that we can have it in the simplest laws exponential form. Now we'll have the 8 as 2 to the power 3, and 3 already is simplified for us. So what we see is that the following, both sides are the same. There's 2 ways we can do it, but let's proceed with this way. You can just divide by 2 to the power 3, and this one divide on that side, and we have when we have the same bases dividing each other, what do? We subtract the exponents. We subtract m and 3 in that case. If it is the case, we have the base of 3 for both sides. We'll now say n minus, there's 1 here, so n minus 1 in that case. Then we now know that it is only true if m minus 3 is equal to 0 and n minus 1 is equal to 0, where they are integers. Then what we now have, we know that m in this case will be 3 and n will be 1. So we have n, which is n plus m, which is 3 plus 1, which gives us 4. So in this case, I just wanted to come back here, because if we can check these two sides are actually the same. 2 times 3, 2 times 3. Now 3 times 2 in this case. So they are the same. In this case, we can actually just equate 2 to the power m. So from this step, we can equate 2 to the power m. It's equal to 2 to the power 3. Thereafter, we have the same basis. We drop them, exponents. Then we have m is equal to 3. And on the 3 part, we can say 3 to the power n it's equal to 3 to the power 1. Then we have the same base here. So what we do, drop the exponents. Then we have n is equal to 1. So that is the same thing. So what we could have done, instead of going through this route, we could have just said, because these two sides are the same, we can now just say the 2 corresponds with this 2 and the 3 corresponds with the 3. Now, we are going to question 2 and question 3. Question 2 and question 3, we are talking about sequences and series. When you're looking at the sequences and series, this is just a brief summary of what we work with. We have the arithmetic and the geometric. Then arithmetic, we can see we have a constant difference. Under geometric, what we have it is defined by the constant ratio. This is R, small letter R, and this one is a small letter D. The general term for the arithmetic is Tn is equals to A plus into n minus 1, close bracket, multiplied by D. Then the geometric one, it will be Tn is equals to A times R to the power n minus 1, where in this case A is the first term, D is our difference, and n in this case it will be number of terms. Same thing applies this side, where A it's our first term, R it's our common or constant ratio, and n in this case it will be number of terms. Then we also look at the sum. So our sum, it is given for the arithmetic, it's Sn is equals to n over 2 into 2a plus open bracket n minus 1 close bracket d. And we have another one when we are given the last term. So this one we are given what? The last term. Where a is still the first term, n is also the number of terms, and t is a constant difference. Then we proceed. On the geometric, we have Sn is equal to a into r to the power n minus 1 all over r minus 1. Or we can say a is equal to Sn is equal to a into 1 minus r to the power n all over 1 minus r. Then we go to look for sum to infinity, where we're saying we do not have infinity for arithmetic. We only have it for geometric. So it is sum to infinity equals to a over n minus over 1 minus r. We do not have n in this case. Why? Because we are going to the infinity. We do not know the total number of terms we have. They are continuing in that case. And we know that our sum to infinity is convergent when r is between -1 and 1. Then we have quadratic in this case. Quadratic where we're saying we have quadratic because the second difference, so we have two differences. Now, under arithmetic, when we have a constant difference, it's just a straight arithmetic. However, we can have two differences where the second difference will be constant. So we'll have our first pattern, then we'll have T1, maybe T2, T3. From there, we'll minus the 2, we'll get a difference here, and we'll minus that, we'll get another difference. We'll just add another one there, T4, then we'll get another difference, which is now, this is the second difference, which is saying it is constant. Then it is given by the general formula, Tn is equal to an squared plus bn plus c. Now to find the values in this one, we start by saying, we look for them from the second difference going up. So say 2a is equal to the second difference. Then after you find the value of a, you will now find the b to say 3a plus b, it gives us T2 minus T1, and we say a plus b plus c is equals to T1. So that's how we work with that equation. Right. Now grade 12, we will have 10 minutes to complete this activity. So this is question 2 of our paper 1, November 2023. Welcome back, veterans. Now, let us now look at this question. Question 2 reads as follows. You are given an arithmetic series, 7 plus 12 plus 17. Let's continue in that case. 2.1.1 determine the value of t91. Now let us focus or let us look at the solutions to this activity. Now find the value of t91. To find the value of t91, what do? We now start with the general formula to say for arithmetic sequence, Tn is equal to a plus into n minus 1, close brackets t. Thereafter, what we do, our value of a from the series, we have it's 7. Then we proceed. We check other values. Now let's say a is 7. We are saying the value of t91 there. Then the difference in this case, we just check. 12 minus the 12 minus the 2, 12 minus 5, 7 is 5. Then 17 minus 12 is also 5. Right. So what we now have there, we have a constant difference of 5 in this case. So our difference is 5. Thereafter, what do we now have? We see, determine the value of t91. So it's Tn, t91. So t91 there, it represents our n. So n in this case is 91. Then what do we do from there? We substitute those values into our formula. A, in a space of a, we put 7 plus into our n, it's 91. So it's 91 minus 1 in close bracket. Then the difference is 5. We multiply by 5 in that case. Then we have our t91, press everything in the calculator is 457. Or this is how you could have done it. So the other way that you could have done it is by doing the following. So what you could have done in this case is to say, okay, I could have done this formula to say Tn is equals to a plus n minus 1 and a d there, where our a, we have a is 7 plus into n, we just say it's n minus 1, the difference is 5. Thereafter, from what you do then, we just multiply by the 5, they distribute the 5, then we have 7 plus 5n, then 5 times negative 1 is negative 5. Thereafter, like terms are these two, 7 minus 5 is 2. There we go. Then we have the general formula there for the series. Thereafter, what we do, now we're looking for t91. So Tn, t91, so in a space of n, we'll now replace it with what? With 91. So we'll now say 5, our n is 91 plus 2. Then we get t91 as 457. And the second one says, determine the arithmetic series. So we're determining the Sn of this equation. Remember? So it's S91. So S91, so now we're not talking about a series. When you're talking about a series, we now say Sn is equal to n over 2 into 2a plus into n minus 1 close bracket and a d there. Now we substitute the values. Our value of a is 7, d 5, and n is 91. So when there is n, I put 91, there. A is 7 in that case. Then our n is 91. It's S and 91, that's what we're working with. And d is what? The difference is 5. Then we press everything in the calculator, we get 21,112. Or we can use the Sn is equal to n over 2. And the one which is a, that requires us to find the last term. And our last term in this case, it will be 459 because we're working with t. Remember, it's S91. In the previous formula, what did we do? We found t91. So we find that when you add them together, add 91, we get how much? 459. So when we're saying S91, we're saying for the first 91 terms or for all those 91 terms. So that means this will give us the last term. So the value of the last term, which is the 91 term, is 459. So we have that. We can see that 457. It's 457, not 9. In this case, just forget that. Right. We now say S91. So 91 is still our n. In this case, over 2 into a is 7 plus 457. then we get the same answer, which is 21,112. Now we're proceeding. They say calculate the value of n for which Tn is equal to 517. So what are we given now? We are already given the Tn value. So what are we looking for? We're looking for n. So from our formula, Tn is equal to a plus n minus 1 t. So what do we now do? We have to find a general formula first, which is general term. What do we now do? Substitute a. In the space of a, we put it is 7 there. We proceed. In the space of n, we substitute n. We don't have n because we're looking for that n minus 1 close bracket. Then in the space of d, we have our common difference was 5. Thereafter, we now multiply the 5 inside. We get 5n. Multiply by that, we get what? Negative 5. Then we have Tn. It is now, it's equals to 5n plus 2. Thereafter, we remember we are now given the Tn. So our Tn is 517. So in the space of Tn, we now substitute with how much? 517. It's equal to 5n plus 2. Then we solve for n from there. Then 5n equals to 515. Then n is equal to 103. Now, let us look at 2.2. 2.2, we are told that the following is given about a quadratic number pattern. T1 is 3. So the first term is 3. T2 minus T1, so the difference between the two, the first one, the first difference we have in there is T2, so the term number 2, and that is 9. So we substitute 9 there. I'm just going to read through everything there so that we can see how to work with that, with the whole information. So in this case, we're told that T1 is 3. Right. They said T2 minus T1. So this, and there's another value here, which is T2. The difference between them is how much? It's 9. Then what else are we told? We are told that T3 minus T2. So another value here, and this will give us how much? 29. So this means just 3 plus. We'll have 3 plus 9 there is going to be 12 in that case. That means when we're saying 12 minus 3, which is going to give us that 9 that we are talking about in that case. So what we now see there, you're going to say this plus that will give us what? 33. Then we proceed to say, okay, this now plus this, it's giving us 33 already there. Then what we do now, the 33 here, it's here. Then we're saying this plus that, it gives us 66. So that's how we get all of those values. So the difference between the two here, T2 and T1 is 9. T3 and T2, we have 21. And this one is 66. Show that T5 is 111. We already had this one, and that we now already know that this is, we know that the difference between, just go back to this one. The difference between T3 and T2 was 21. Thereafter, we can know the difference between the two, because these ones we need to find them going up. When you know the difference here, it's going to be what? 12. When you know that this is 12, then this plus that, this will also must give us how much? 12. Because the second differences must be constant. Even this and something else must give us 12. So what are we going to do now? We're going to say, okay, this plus that will give us 33. Then this plus 12, they will give us how much? 45. Then we proceed to go back up to say we have 33. We've had this 33 now. So the 33 plus 33 gives us 66. Now, this is what we get. Then 66 plus 45, we get what? 111. So that's why I was just showing you how I got all of these values here. So this is how you work. Start here, because we're given those values. Just going to circle one was given. We're given that, and that. So how did you work with it? What we said is the following. So this plus that gives us 12, 5. then we have the 2 there. Then when we say 21 minus 9, you get 12. However, we know that this difference must be constant. We just say this in a certain value here will give us 12, and this will give us 12. Thereafter, we now say 21 plus 12 will give us 33. So 21 plus 12 will give us 33. And we proceed and say, okay, 33 plus 12 again will give us 45. We come back here. We already had this 12 now. Then we say 12 plus that will give us 33 in that case. And we now know that this and that will give us now 66, and this plus that will give us 111. So that is proven. Now T5 is 111. Another way that you could have done it is to find the T5 using the our differences that we can work with in this case. So what we can do in this case is the following. We can now find a general formula to saying 2a is equal to 12. So 2a is equal to 12. Then we find a there. Our a is 6. We proceed. The second one is 3a plus b is equal to 9. Then the 3a in this case, we'll say 3a plus b. Our a is 6. We'll say 3 into 6 plus b, it is equal to 9. Then you solve for b. Then b is negative 9. Then we have a plus b plus c is equal to 3. So it's a plus b plus c is equal to 3. So our a, we have it. It was 6. Then b was given to us as negative 9. Then, so it's going to be 6 minus 9 plus c is equal to 3, which is equal to the first one there. Then our c is equal to 6. We substitute that into our general formula. Then what we now have in the space of a, so we're saying it's T5. So n it's 5 because we're looking for 5. T5. Now in the space of a, we substitute 6. The space of n, it's now 5 squared plus into negative. What is b? Our b in this case is negative 9. And we have n is 5. So plus 6, then we get 111. So we can find a general formula first, and we can now use that to find our T5. Now let's say show that the general formula already we have done it in the previous question. So we'll just repeat what we did there. So what we did to find this, we just said 2a is equal to 12, then we solve for a. So that's what we did. Then we solve for a. Then a is equal to 6 on the first one. Second one, we say 3a plus b is equal to 9, which is this 9. The second one on that one. So what we'll have now, 3a plus b. In the space of a, we substitute the a, which is that 6. Then plus b is equal to 9. Then we solve, we find our b as negative 9. Then we go and find the last one. A plus b plus c is equal to 3. So all of these are equal to 3. Then our value of a in this case will be 6. Plus our b is negative 9 plus c is equal to 3. Then c is equal to 6. Then we substitute into the general equation. Then our n in this case, a, we have it. We have found a here. A is 6. We have b is this one, and c we have it is that one there. Then we substitute to say a is 6. So 6n plus, which is now the negative there, negative 9. Our b is negative 9 n plus c. There we go. Then we substitute what we now get. We get 6n squared minus 9n plus 6. That is our Tn. Show that the pattern is increasing for all values of natural numbers. So the natural numbers or the value, all natural numbers, they start from what? Elements of natural numbers, they start from 0. They start from 1. 0, 1, 2, 3, 4, 5. So we're saying show that the pattern is increasing for all the natural numbers. So in this case, what are we saying? We are saying we look for the derivative, and our derivative in this case must be greater than 0. Why? Because all of the natural numbers are greater than 0. They start from 1, 2, 3, 4, 5, 6, 7, 8, 9 in that case. So what do we now do? We now find a Tn. We'll find the first derivative of our Tn. We'll first find the first derivative. We're going to say 6 times 2 is 12. So we have 12n. 12n minus 9. So we can know this 1 here. 1 times 9 is 9. Then n minus, so it's 9n. So in this case, it's going to be 1 minus 1, which is 9 to the power n and 0, which is 9, because any number to the power 0 is 1. Plus 6 is a constant, so it will fall off in that case. The differentiation, when you differentiate a constant, you get a 0 there. Now we have the first derivative there. Then you say all of these are greater than 0. Then we solve for n. Then n is greater than 3 over 4. So n is increasing for all values of n is an element of natural numbers where n is greater than 3 over 4. Let me just go back a bit there. So what we could have done there is, we understand that this is a quadratic equation. So we can use to say, in this equation, so we are looking for when n will increase. In that case, we will have what? It will be natural number. So we're looking for it to be, or to have values greater than 1. So what are we going to do here? We're going to work from x, it's equals to negative b over 2a. So that's what we do. You just find the value of the turning point here. Then from there, you're going to use that values. And those are the values where the pattern is increasing. It's increasing from the side into our neutral numbers. So sometimes, even if it was increasing to, if we're not talking about neutral numbers, we're going to even include this side. Now, we're looking for neutral numbers, so it is on the positive side in this case. So negative b, so it's going to be negative b. Our b in this case is negative 9 all over 2. What is a there? A is 6. So 9 over, so this is what we're going to have, 9 over 12. So 9 over 12 is 3 over 4. So which is the same thing that we have in that case. So we can use the turning point there because this is a quadratic equation. Now, we are given, so you will be given only 5 minutes to complete this activity. So let us now work on question 3.